So hi everyone, welcome to the summit. My name is Heitor Lessa. I'm a solutions architect for AWS, working for Amazon for about 4 years. That's my third role. And for the last 3 years, I've been working with best practices with a number of customers. Is that sounding good? I'm not sure, it sounds like it's echoing for me. Just gonna stay away from this then. Cool. So I worked in support previously as a technical account manager and also support engineer, which I worked from companies like startups to enterprises. And most of them were also interested in automating those best practices. Stephen will be joining afterwards from Pixel to talk about his story about automating these best practices. So what today is all about is, if in case you haven't heard about these two tools, Trusted Advisor and AWS Health are the tools that are going to help you to automate those best practices on AWS, whether you are as a customer just starting on AWS, or if you are a customer further down the road. And lastly, I want to give you some examples and some open source tools that you can leverage to start working on these automations in case you haven't started that already. So this is an AWS architecture. It's pretty simple when you look at that. If you're starting on AWS, that might look a bit scary. Don't worry, wait until the next slides. Now, as you grow on AWS and you start building high availability and working with multi-AZs, for instance, your components, your services you use start growing. So I presume some of you might look into something like this already. So when you look about a single EC2 instance or a single RDS database, which is a managed solution, it might be easy to find out who actually left that database running overnight. It was supposed to be shut down last night. Or if it was a developer who forgot to tag the instance name correctly and instead named the instance called Batman. I've been there. So today's talk is all about how can you automate these pieces? How can you make sure that people are not forgetting the things, all leftovers? And how can you make sure that as you grow in AWS, high availability and cost still go hand in hand? And as you grow in AWS, it shouldn't necessarily grow too much in your bill as well. How can you do this? So if you haven't seen this before, this is a free service that we offer called Trusted Advisor. So Trusted Advisor basically scans your AWS account and will tell you, based on our best practices, what are the things that you should be doing better and how you can do those things. And you can also set up notifications, so you can receive weekly emails to say, for instance, how much am I spending on AWS in terms of how much can I optimize? What are the security breaches or security best practices perhaps I'm not following? Is there anything that I could possibly do better? As you grow in AWS, imagine if aggregating that data across multiple accounts, how much you'll probably not be seen, or how much you probably didn't even know existed in your AWS account. From Trusted Advisor perspective, we already helped thousands of customers save over $500 million just in the billing. When I worked in enterprise support before, one of the quotes that struck me was a customer said to me, "It feels a bit crazy that you give us a tool that will tell us how to spend less on your platform." Yeah, in fact, that's what Trusted Advisor does, one of the pieces. When you think about how does it work, we segregate those data, those advices, in what we call scores. So we score you based on red, yellow, or green on seeing how good you are. And based on those numbers and those scores, you should be able to receive that data and add automation on top of that. So you would see things on security, fault tolerance, performance, and availability. So one particular customer, when I was starting AWS, actually had that particular quote, which for me was a bit of a surprise. Just Trusted Advisor, without a solutions architect, without people helping them on a daily basis, just the tool itself helped them to save 33% on a monthly basis. That's a lot. How did they do this? So on the highlights that we asked them, what specifically Trusted Advisor helped you? As you grow on AWS, you may have some EC2 instance that you didn't know how much memory you would need, how much CPU would you need, and you just launched. It's fine. You used it. After a while, perhaps you forgot. Or perhaps the workload changed, and you never actually changed the EC2 instance type anymore. So what Trusted Advisor helped them was to say, this is a list of hundreds of instances that perhaps you should reconsider. Perhaps you don't need the M4 X2 large anymore. Perhaps you need a T2 micro now. Perhaps you need a C1, C4. I don't know. That changes. And also, One that I've seen so many times that I always tell everyone, please go Trusted Advisor. I'm sure you have those. Every time you have outscaling or so many EC2 instances, as you kill those EC2 instances, if you have an EBS attached to it, an EBS volume, that EBS volume might be living there already, and still nobody's using, and still you're paying for that. So Trusted Advisor will tell you how many EBS volumes you left behind. And that number from some customers can go as high as having probably $30,000 a month. So don't waste that. Kill those resources. So how do you start building automation into this? Trusted Advisor, as many other services on AWS, we provide you an API. So how would you build that? If you haven't seen Lambda before, our serverless solutions that allows you to run any code without managing infrastructure, you can trap these APIs from Trusted Advisor in a service called CloudWatch Events, which basically is an event hub where near real-time events come and go. And as these events come, you can call a Lambda function to run a code. So let me give you an example. So imagine, for instance, on today, you've seen that someone forgot the security group and opened the SSH to everyone, or opened the access to a certain EC2 instance to everyone. Or you have a database that nobody accessed that database for the last 7 days, and it's developing environment. Why would you need this? Instead of having people to manually go to the console and click and disable stopping that database or doing something, you could trap that API from Trusted Advisor, call a Lambda function, and do the code. And by that, you can start building automation or even open support cases and so forth. Of course, automation is beautiful. You can do a lot of other things, but I also have been on the other side of the fence where sometimes automation can go wrong. And one thing I have to remind everyone is that it will definitely cost you be a concern, but you definitely don't want to be spending time stopping or explaining to someone why your little script stopped a production environment because you believe that was a cost issue. So yeah, think about it. So of course, show me the money. Where is the money spent? How Trusted Advisor knows? So this is just one check out of over 40 checks in Trusted Advisor that will tell you specifically 14 out of 17 instances. So in other words, only 3 instances have really been utilized. You have to take an action on this. So low average means probably not using CPU enough, or IOs has been quite low in the last 14 days or so. So have a look at that. On the tools we're going to give to you on the next slides, it will be something like this. It's a Lambda function that will look into your EC2 instances from Trusted Advisor. Trusted Advisor will say, these are the list of low utilization instances. And Lambda will look into say, are they from development environment? Or are they tagged as cost center X? If they are, then stop those instances for me and notify someone that those instances have been stopped. If you're interested in those, these are the 2 links that you can check it out. So it's on our GitHub, AWS/Trusted Advisor tools that contains a Lambda function. But you shouldn't stop there, really. I added the extra link to best practices, where that link you'll be able to find all the checks that Trusted Advisor does on your behalf, and what that actually means, and how you can programmatically get access to a single result only, instead of scanning all the checks that you probably don't need. So when you think about health, if you haven't seen that from the reInvent last year, other customers, so many customers asked us in particular that sometimes when there's an issue on their underlying infrastructure, you wouldn't want to go to status.amazon.com or status.aws.amazon.com to see if your underlying infrastructure has been impacted or not. You actually wanted a dashboard to say, if AWS is having an issue on an EC2 service or a service with API errors, you wanted to know if your account has been impacted or not. And that's exactly what health is all about. So if you're interested in this, health or PhD has a dashboard that's personalized per account basis that will tell you exactly if there's something wrong happening on the underlying infrastructure, what specific is happening, and if there are any action that you could possibly take to remediate that. Or perhaps schedule changes. Sometimes we need to recycle some hard drives, and you should know that in advance. As you have multiple accounts, it's difficult to go to all these accounts, aggregate that data. So health does that for you. Well, as I kind of already talked about this, the extra thing that I forgot to talk is about notifications. Like again, as any other AWS service, we provide APIs. As health discovers issues on the underlying infrastructure, it can emit events which you can trap, and you probably know where I'm going next. Health, in one way, is to provide you primarily transparency over what's happening to your account. And so you don't have to panic over seeing something on the dashboard or not, and actually tell you what actions you can take, and not just sit around and say, oh my God, what else do I do? Actually talk to us. Sometimes there are some actions that you probably need a solutions architect to help on reviewing these architectures. So health is actually quite smart on telling you all these pieces. What does health capture? So health divides into two, what we call resource level. So it can tell you, for instance, on a Cognito level, if you have, Cognito is our managed service for federation, for data identities or synchronizing mobile data between different devices. It can tell you from Cognito whether permissions have been incorrectly set and no user will be able to authenticate from that particular identity. Or you can say for an EC2 instance, you have an EBS volume attached, and now it says that particular volume has a performance degradation, and you should move away from that volume. So you can automate all that and automatically queue or take actions based on those events. So this is how it looks like when you think about health on a dashboard. So basically, it will show you everything that is open, something that's is going to happen or already happening. The schedule changes, where you can see some instances going to be rebooted or something in general, and everything from the past, in case you want to have a look. So if you haven't seen this before, you should be able to see this little blue button, actually not blue, yellow, colorblind, I guess. And also from here, that's how you can access. Or probably you've seen this before, but you never paid attention. On the console, we introduced this last year, which is it's a big bell over there. That's health. If you go over there, if you see that little button over there, and you see any open issues, you should check this out. Okay? But how does health work? How does he get all that information from you? How does it do in a way that it doesn't impact your environment? So all these AWS services, over 70 plus, will emit events to health, should tell health exactly what are the events that they should know about it. If there's an issue on our side that previously the only way to find out will be opening a support case, health will know that in advance and will know specifically which account that event belongs to, and then we will emit an event to your AWS account. And then you can trap that, do whatever you want afterwards. And so you can access that through an API, which is obviously what I'm going to talk next, or through the dashboard. Or perhaps you can even send notifications via email. You choose. So a simple way to do the automation, as I talked about Lambda before, is receiving those events from health straight to CloudWatch events, and then those events we call Lambda function to do something. Of course, I'm not going to only tell you how to do it. I'm going to give you some resources so you can actually have a look. If you're interested in doing this, and you are looking for open source tools, check out this particular GitHub, AWS/health tools. They will give you some of the examples I'm going to talk now. Unfortunately, I can't cover all of them because of time, but I just can give you some idea on how you can open source, how you can automate those tools using those open source tools. So a simple example would be, perhaps some of you already use Slack or any other chat tool, chat ops, where you kind of centralize all the notifications coming from one place. So we are providing you a Slack notification that basically will hook up any events that come from health to send to a particular channel. And that also means other operational channels. For instance, if there's something that happens from security perspective in your account, you should also receive those messages. Or perhaps via email, SMS, you choose. And on the other side of the spectrum, we have something more elaborate. Let's go through this. So the first one is a notification via Slack. All you have to do is a CloudFormation stack. It's a single click, either through this link directly or from the GitHub that I just mentioned to you. Basically, you click on that stack, and you'll be able to specify what is the channel you want to send a message to. And when you receive that message on Slack, this is how it's going to look like. You see that an issue has been detected in what particular service, and then a link specifically to that particular issue telling you what to do will be sent to a Slack channel. So that allows you to receive all those messages in a single place, so you don't miss those. And next is another one which I mentioned previously. Imagine that your database, for instance, is running, or even another workload, application server, is running on an EC2 instance that now you notice that the performance has been degraded, but nothing has changed. You haven't really received new users, but you see that from CloudWatch metrics, you see that something diverges. And when that happens, if it's related to an underlying infrastructure, now you have the visibility. This particular open source will give you an automated way to say, if your instance has been impacted by an underlying infrastructure issue, because your volume has been degraded or a hardware, whatever is happening, we'll be able to delete those instances or even stop those instances. So when you launch that stack, all you have to tell is how you're tagging those instances so you can know what to do, and if you're doing a dry run or not, and then you can define whether you want to stop or terminate. Like we said previously, you don't want to poke around your production databases. You want to do something smarter than that. And next, this is my favorite one in particular. If you're running on a DevOps or Agile methodologies, you probably are aware of continuous integration or continuous deployment. That is a perfect idea in so many ways, but at the same time, when you're having an issue on the underlying infrastructure, the least you want to go through experience is if you have a set of stages, beta, gamma, production, and so forth, you want to avoid going through all these stages if you know that is an issue happening underneath. What you want to do is avoid all these failures that you know is going to happen, to stop at the very beginning. As you receive a Git push from the developer, you want to make sure if there's an issue, stop right there. Wait and do something afterwards. So this particular example, all you have to do is you launch this CloudFormation stack, you specify what is the code pipeline stage, and once an issue has been detected on your environment, Lambda will automatically disable that stage transition from source to a build or whatever stage you have it, and will tell you why. So that's why it's one of my favorite ones. Of course, there are much more to explain, but we don't have much time. I would like to introduce you to Stephen, who has a lot more to share as well. Thank you.
Hi there. My name is Steve Gran. I'm Senior Infrastructure Architect at Pixel. We're building a SaaS platform for video delivery. We've been running this division for about 3 years, and I just want to share with you some of the ways we build operational resilience into that platform. Like most of you, we have demanding customers, tight SLAs. They're looking to bring large workloads to our platform, and they want low latencies for that workload. At the same time, like everybody, we have difficulty recruiting people, so we need to maximize the work we can get out of our operational resource, and we need to keep our costs down. It's not like we can reduce latency just by running an enormous estate and hope for the best. So in my role as infrastructure architect, what I'm looking to do is find common reusable patterns that we can apply across our platform to keep ourselves healthy, to keep ourselves always on. And so these are some of the most common out-of-the-box building blocks that AWS provides, and this is 95% of web operations right here. You have an application health check endpoint. You put that into the ELB. The ELB will terminate any unhealthy instances. If you run your applications as part of an auto-scaling group, the terminated instances will automatically be replaced with new healthy instances. You stay in business, no downtime just because of a lost node. If you can couple that with CloudWatch metrics and CloudWatch alarms, you can scale based on demand for your service. You can scale up when you're busy and down when you're idle. This, like I said, this is bread and butter stuff. Probably lots of you are already doing these sort of things. So I'd like to take you through some of our worked examples, how we're doing things. API servers, we've pretty much just covered that. This is straightforward stuff, and all of those building blocks exist in AWS right now. Typically, you want to auto-scale on things like CPU use or request count, whatever makes sense for your application. Because we do video, we do an awful lot of transcode for people, and that's a slightly harder case. We don't have ELB health checks to tell us when our instances are unhealthy. And also, we don't have a single out-of-the-box CloudWatch metric that tells us we need to scale up and down in response to workloads. So we've created a custom CloudWatch metric that tells us about the queue length of outstanding work And that takes into account the number of workers we already have in the fleet right now. So if there's 10 jobs in flight and 10 workers, we get a metric with a value of 0. So this is great for scaling up. It's great for scaling down. The problem, of course, is these are transcodes. This is a customer uploading a 100 gig 4K mezzanine asset and asking us to transcode it. So we can't scale down those instances halfway through transcoding that enormous asset, or else we have to start back over again. The customer sees higher latencies for their transcode jobs. It's a worse experience for everybody. So we use IAM instance profiles that allow those transcode workers to set scale-in protection on themselves when they're actively transcoding, and then remove the scale-in protection when they're idle. So now we can combine the CloudWatch alarms and just treat them as a normal auto-scaling group. Only idle instances will be removed from the pool, and the customer has a better experience. The story for our container fleet, we run a lot of Docker, again, probably like lots of you out there. The story for our container fleet is similar to our transcode workers. They're not API services, so it's not exactly as simple. There's no single out-of-the-box metric. But here it's complicated by the fact that the container scheduling software we use doesn't expose a single metric that says, I'm full. We get a half dozen metrics that say the CPU is 75% utilized, the RAM is 50% utilized, on and on for each of the resources exposed by the container scheduler. So we've constructed what people call a synthetic or a composite metric based on these. And so each agent will submit one metric to CloudWatch that says, I'm 75% full. That 75% might be CPU or RAM. From my point of view, running the fleet, it doesn't really matter. All I need to know is how full that machine is. This allows us to scale up and scale down our container fleet as our Docker workload increases and decreases. I think this is a kind of a powerful pattern, identifying a key metric that identifies how busy your service is and scaling your fleet based on that. You might have to construct that metric out of multiple metrics. It might be a single out-of-the-box metric available from AWS right now. But so there's this thing about pets and cattle, right? And pets, you stay up and you keep them, you nurse them back to health, and cattle you slaughter when they're poorly. Those are all cattle. The hard part is your data layer. Those are your pets, right? You can't just auto-scale Cassandra or Kafka. They might have terabytes of data on the local instance. So you can't just add one and then take it away 5 minutes later. So what we're looking at here is managing resilience in that layer, making sure that unhealthy instances are replaced and minimizing the time when our operational resilience is impacted by instance recovery. So the pattern we're doing here is we're relying on EC2 health checks, system health checks that tell us about the underlying AWS hardware health. And we have CloudWatch alarms that will automatically reboot unhealthy instances, automatically relocate instances where the underlying hardware has become faulty. And then we have user data and boot time scripts that will reattach persistent EBS volumes to the instance after the fault is corrected. And what this gives us, instead of having to replicate half a terabyte of data to the new instance, we might only have to replicate tens or hundreds of megabytes of data. This dramatically reduces the time during which our operational resilience is impacted. And we're quite happy with this pattern so far. We're looking at also doing it with things like Cassandra, although it's slightly more complicated there, and I don't want to bore you with too many details. So the results for us have been, we have lower transcode times for our customers. We have a higher confidence in the platform. It's almost entirely hands-off from the point of view of our engineering team. And that gives us a lower TCO, right? Our staff isn't spending so much of their time running the fleet. Our staff is spending their time doing work that we want them to do. And our AWS spend is lower because we can meet the latency requirements from our customers for things like transcode or API requests without running at peak all the time. We can scale the vast majority of our fleet up and down depending on load. Another thing we can do for cost savings is, like all of you, we have test environments, dev environments, and so on. And while they're hugely important for our productivity, your devs go home at the end of the day, go to the pub. So we turn those environments off every night. We have a scheduled job that deletes all the resources associated with our dev and test environments, and we have another scheduled job that runs in the morning that recreates them from scratch. We did this initially as a cost-saving exercise, right? If you only run your dev environments for 12 hours a day, it costs you half as much. It's fairly straightforward math. But it gave us resilience as a bonus. Now, every morning, we have a full end-to-end integration test of all of our automation code. If you come in the morning and your dev environment is running, nobody broke anything. That's a pretty good win for us. We know that disaster recovery works because we do it every single day. So the takeaway for me is it's really, really hard to do what AWS has done. They've given me a series of reusable building blocks and allow me to compose those in multiple complex ways to build platform and operational resilience. This has freed up my engineering staff. They don't visit data centers. They don't wake up at 4 in the morning to fix things. They don't fix config by hand. They write code. They make a better platform. They bring business value. So thank you all very much for listening to me. Thank you for having me. We're hiring. We do cool stuff. Come talk to us if you're interested. Thank you.
Thank you. Okay. Okay, so just to finish that off, we showed you a few services that you can use to automate those best practices, but this is purely just a few of those. In practice, what I particularly seen a lot in the field is Lambda being used as a glue with Trusted Advisor and CloudWatch events to automate all these things. But automation shouldn't be really stopping there. There's a bunch of customers who start, and then they probably automate 1 or 2 things, and then they leave that off. The reality of automating those best practices shouldn't only be seen as a way to reduce or optimize your AWS billing or spend, but more so into freeing those resources you have, those very smart people, talented people that should be doing something else, rather than trying to wrangling themselves into patching, into automating those, creating those little scripts and waking up in the 4 a.m. to do something. Automate those bits and pieces. Let people to do what they're supposed to do. When you free them to do some of the boring jobs, as I like to say, you would see them doing a lot more interesting work for you. And as you automate this, I've seen customers where they use Trusted Advisor and Lambda to build gaming days where you see big dashboards, big TVs on showing how well a particular product teams internally would be doing against each other. If you see all these red and yellow scores from one from the other, you would say maybe you should have a look at those. So allow yourself to receive those weekly notifications and automate as much as you can, because at the end of the day, they're only going to benefit you and allow you to deliver those business values much faster. That's all I have for today. I really appreciate for your time for being here. We have Ask an Architect over there if you want to ask any questions in particular. Otherwise, we're here for the last 5 minutes. Thank you.